Yeah. So, hello everyone. It is with great pleasure that we welcome you all to this webinar. I'm your host and speaker, Yuvraj Sonare. Thank you for taking your time to join us today as we talk more about Introduction to DevSecOps. Okay, all right. Here we will go through why do we need DevSecOps, how do we implement DevSecOps, how security can be integrated into the DevOps pipeline. We will briefly discuss popular tools and we will end up with some examples of DevSecOps implementation. Before we start, I would like to know that how many of you are familiar with DevSecOps? Here will be poll on your screen. Okay, we got responses here. So, as we see, most of you are not familiar with the DevSecOps. This session will be beneficial for you to understand the nuances of DevSecOps. Before we dive into DevSecOps, let's have a quick overview of DevOps. Developers checking the code. This triggers an application delivery pipeline. As part of the pipeline, unit tests and automated tests are run. Applications is deployed to the test environment where more tests and other tasks can be taken up. If the application works well and necessary approvals are in place, a new version is released into production. This automation optimizes the deployment of applications into the various environment with no to minimal efforts from developers and testers. So, this is Dev and Ops collaborating to streamline the deployment with workflow enables the early detection of anomalies and faster deliveries. Okay, then application is deployed into the production and we think a job is done. But is it really done? Because what about security? Be it any industry like healthcare, banking, social media, etc., security is of prime importance. Breaches and data leaks are detrimental to your businesses. Have we done enough to ensure that the application is not vulnerable to security hacks, data theft, etc.? And maybe not. DevOps helps us with faster releases, but when we make sure that security is an integral part of the operations, we move from DevOps to DevSecOps. Here we will talk about the shortcomings of DevOps. As we just noted, security is not part of the DevOps pipeline, even if some applications consider security, that is a second thought. In such cases, security review or audit takes longer. Earlier, we had monolithic applications. They expose APIs to communicate, which are prone to attacks. Security review needs to look at all these touch points. However, applications nowadays have evolved into microservices, which spawn more services and exchange information between them. Each touchpoint is a potential target for hackers. So the review must test and verify all these touchpoints. Security tools that were developed earlier and are still popular have not kept with the changing nature of applications. And because of these aspects, security review takes much longer, and this delays the product's availability in the market. To ensure the security of the application, following factors shall be considered. Like the development team used a library that has vulnerabilities, licensing issues, etc., which they are unaware of. Maybe the application has a password in plain text somewhere, or the container itself is compromised, or Kubernetes is configured improperly. For these factors to be taken care of, DevSecOps is useful. Now, let's see how DevSecOps helps us overcome these limitations. Instead of just focusing on security after the DevOps, the key is to moving security to the left of ops. In other words, making security checks part of the development process. The shift left testing approach means baking security into your applications from the beginning. Instead of just waiting until the final stages of the delivery, the obvious advantage of doing this is that you get to identify and resolve potential vulnerabilities on time. And the earlier you find any bugs, the cheaper it will be for you to fix them. However, this best practice has its challenges. A common challenge is that incorporating security in the existing DevOps process will disrupt it, but the advantages overweigh the pain. So, we already talked about traditional DevOps workflow. In that, security is additional activity and taken up afterward. Shown on the right in the image here, you see security considered at the end of your CI/CD pipeline. We need to start thinking about security right from the beginning. So, security should be infused or integrated into each step of the DevOps process. Developers need to ensure that security is embedded in the code. As soon as any security issue is identified, it is fixed right away. The security team should play the role of a facilitator or advisor to developers and operations teams, to helping them to understand and manage security. To make sure that the security is given due importance, security measures need to be put in place. So, here we see some security measures. Security teams should create security policies, train or teach developers and the operations team to interpret the output of these tools so that they can identify and fix the issues themselves, and select proper automation tools and platforms for the detection and identification of any security issues and vulnerabilities. It could be security scans, code quality checks, automated security tests of the applications, and etc. There are different activities involved. These are pre-commit hooks, then software composition analysis, SCA. Next one is static application security testing, SAST. Then we have dynamic application security testing, DAST. then security in infrastructure as code, and secrets management. So, how can we implement DevSecOps? There are multiple stages of a pipeline where various security tools can be integrated. In the continuous integration phase, developers have something called pre-commit hooks installed on their systems. So, pre-commit hooks are run first before you type in a commit message. It is used to inspect the snapshot that's about to be committed, to see if you have forgotten something, or to make sure tests runs, or also to examine whatever you need to inspect in the code. It checks for sensitive information if a developer accidentally is about to commit. For example, a developer might accidentally add secrets or keys as a part of the commit. Pre-commit hooks would prevent the user from committing. A developer would get an error message stating that you are trying to commit some sensitive information, which would prevent him from committing the code. Similarly, we can have secrets management. It's nothing but where you can manage secrets. These days, we have infrastructure as code. There are many configurations and sensitive information, such as credentials, and all are being passed in your code. So we can use secrets management to manage credentials instead of just passing those in the configuration files. Secrets management refers to the tools and methods for managing digital authentication credentials, including passwords, keys, APIs, and tokens for use in applications, services, privileged accounts, and other sensitive part of the IT ecosystem. Next is software composition analysis. We can call it as SCA. SCA scans open source libraries used within an organization's code base and identifies vulnerabilities. It can also detect open source licensing challenges that conflict with the organization's software licensing policies. Today, many software applications contain at least one open source component, and which makes SCA valuable in most organizations. In the pipeline, you see SCA should run just after the build step. The pipeline should be configured to fail if any SCA issues are detected. The next thing is static analysis security testing, or we can call it as SAST. SAST scans an organization's entire code base for a broad range of vulnerabilities, including the critical risks identified in the WASP top 10. SAST is a common and powerful method that should be used by all the organizations due to the vast number of tools available and their ability to detect basic vulnerabilities in the code base. A SaaS tool should be configured to run just after the build step. After the scan is complete, the SaaS tool can publish the results directly to the build console and prevent the pipeline from moving forward if standards aren't met. Next stage we have is the dynamic analysis security test. In short, DAST. DAST crawls a running application and attacks it as if it were a malicious user. DAST can detect issues such as XSS, unencrypted data transfer, and TLS certificate verification. DAST should be performed after the application has been deployed to a test environment. The pipeline process should be configured such that results are analyzed and the pipeline is halted if any unacceptable vulnerabilities are found. Many DAS tools are part of security suites that also include SAST. Once you are done with DAST, The next stage is you could implement a vulnerability assessment tool that will scan your infrastructure to see if any vulnerable services are running and do a vulnerability assessment on them. Then we have compliance as code, which can be run on your production setup. Compliance as code refers to tools and practices that allow you to embed the three core activities that are heart of compliance. So the three activities are prevent, detect, and remediate. The next one is container scanning, rather container image scanning is the process of scanning containers and their components to identify potential security threats. It is a fundamental process of container security and the number one tool for many teams looking to secure their containerized DevOps workflows. The adoption of containers has revolutionized the application development process by enabling DevOps teams to continuously deliver, deploy, and update applications. But this is unprecedented speed and flexibility comes a downside. Container environments are extremely vulnerable at every stage of the environment. Then we have continuous monitoring. Continuous monitoring comes in at the end of the pipeline. Once the software is released into production, continuous monitoring will notify dev and QA teams in the event of specific issues arising in the prod environment. It provides feedback on what is going wrong, which allows the relevant people to work on necessary fixes as soon as possible. And finally, we have vulnerability management, which is the process of identifying, evaluating, treating, and reporting on security vulnerabilities which are present in the systems and the softwares that runs on them. This implemented alongside other security tactics and is vital for organizations to prioritize possible threats and minimize their attack surface. Okay, I will run you through this all over again. So we have a developer here in the picture. He is trying to push the code to the repository, and the pre-commit hook will prevent him from committing any sensitive information to the repository. Then we have a CI part or CI tool that will run a SCA to check if there are any vulnerable components in the code, and the SAST will look for any security code issues and then push the results to the vulnerability management system. Similarly, we have DAST scan. It scans and push the results to vulnerability management. Like this, we have various other stages such as vulnerability assessment, container scanning, and compliance as code, which will then push the results to vulnerability management system. So vulnerability management will keep track of all the various results and it gives us a central management dashboard where you have all the reports. Imagine if you don't have something like vulnerability management system, then it's really difficult to keep track of various results. They are all scattered here and there. This helps you manage things in a much easier way. Then we have security incidents and responses where we use the monitoring system. We also have a web application firewall being installed on production server to prevent some virus attacks on the production environment. There are several other options in various firewalls, especially in the commercial domain. Before we move further, I have got another poll for you, and I'll be running that straight away. Does your DevOps pipeline include any of these security activities that we'll just discussed, such as pre-commit hooks, SAST, DAST, or etc.? Okay, I'm getting responses back from the audiences. Okay, I got all the responses recorded. So I hope that this will this webinar will be most of you would like to include some or more security activities in your DevOps pipeline. Okay, we'll see the transition from DevOps to DevSecOps. DevOps and DevSecOps are closely related to agile development methodologies. Both of these approaches have quite a few similarities, like relying on collaborative culture to realize development objectives like fast iteration and deployment, using automation during the application development process, and actively monitoring and analyzing data to drive improvements. On the other hand, DevSecOps and DevOps are set apart by their focus. DevOps focuses on meshing the development and operations teams. The two teams collaborate throughout the development and deployment process to implement shared goals, which greatly optimize the speed of delivery. As DevOps teams race to increase the frequency of deployments, security is often the first casualty. DevOps has evolved into DevSecOps. Organizations have come to realize that the DevOps approach could make applications prone to security vulnerabilities. So rather than considering security at the end of the development pipeline, DevSecOps integrates security in the entire pipeline right from the beginning. So DevSecOps seeks to have security integral to the software development lifecycle. There are many tools in the market to implement DevSecOps, and here I have listed some tools to counter threats. We have threat modeling tools such as Threat Playbook, Threat Spec, and Microsoft Threat Modeling tool. For the pre-commit hooks, we have Talisman. However, there are few other tools like Git Secret, Tufflehog, and similarly, Bandit is for static analysis and security testing that runs on Python based code. We have SonarCube, which supports multiple languages. Then we can use IDE plugins and secret management. For vulnerability management, we can use ArcherySec or Qualys, and we have Defect Dojo. Defect Dojo is an WASP tool. For DAST, we can see WASP Zap or W3AF. Then we have some security in infrastructure as code, as we can use OpenVAS, Clear, or OpenSCAP. Then we have some compliance as code tools, Inspect by Chef, and Kitchen CI, and few WAF tools like Mod Security. Okay, so here I have received a question asking for how many of these tools are open source. Okay, so in this list, I have listed most of the tools are open source, like ThreatSpec, then Talisman, Dependency Check, then we have ArcherySec, then Inspect, and Mod Security. So these are some open source tools we have? We come to this question: does programming language matter? Answer to this question is yes and no. Some tools work across programming languages like SonarQube, and some tools suits best with one programming language. The major difference is in the stage of software composition analysis and static analysis security test. We will see the implementation example using Java. In the static analysis for Java, we have dependency check and SonarQube for SAST. Another example using .NET. For the .NET environment, you can see a .NET Retire for SCA and .NET Security Guard for SAST. There are several other tools that you could use based on the need and the environment setup you have. Now we'll see some benefits of DevSecOps. The most important and obvious benefit of a DevSecOps approach is that it will improve overall security, uh, helps in the earlier identification of vulnerabilities before it starts affecting the entire application. By implementing security practices to the development lifecycle, organizations are able to reduce the risk of cybersecurity breaches to great extent. And with this, we come to the end of this webinar. And I would like to thank you all for your participation. And at this point, we would like to invite questions if there are any. Please do let's share. I do see a few questions in the chat box. So I'm going through the questions one by one. The question is, what is the impact on deployment performance if we include the security aspect? Or what additional factors do we need to consider? Okay, let me answer it. It won't affect the performance of the deployment. As I said earlier, DevSecOps isn't a quick fix or a temporary solution. It's a long-term implementation that will help you ensure that an organization can achieve and maintain software development lifecycle practices. And if I talk about factors to be considered, the first one I would like to tell that retraining needed for both the developers and security team. Second one, we can change the workflow what we have in the existing environment, and then we can have good communication between developers and security team. Okay, moving to the next question, how secure is secrets management? Okay, so let me answer. Secrets manager stores the encrypted data key with the protected secret data. Whenever the secret needs decryption, secrets manager requests to decrypt the data key, which secrets manager then uses to decrypt the protected secret data. Where we can use secrets management to store our sensitive information. All right. And in case you have any questions, you can reach out to us. Contact details are shared on next slide. And definitely, we will help you to implement DevSecOps for different languages with the help of right tools. And a recorded version of this webinar will be available on our website in a week from now. Also, We will send you an email with the link to access the webinar. Thank you so much. Thank you all for joining this webinar. Good day.